Good day. My name's Toby Walsh, and I apologize for not being there in person. I'm actually on the plane flying to Montreal. Unfortunately, I couldn't get there any quicker, but I will look forward to seeing many of you in person during the next week. I want to talk to you today about a paper that is appearing in the technical track of IJCAI on equitable mechanism design. The setting is one of the simplest social choice problems, that of facility location, where to locate facilities or a facility to serve a bunch of agents as fairly as possible. And we're looking at one of the simplest possible settings for facility location, the one-dimensional problem where we're locating facilities along the real line. Now, many problems can be seen as one-dimensional problems, deciding the optimal room temperature for a classroom or deciding the optimal tax rate for a bunch of people. And many multi-dimensional problems can be reduced to a sequence of one-dimensional problems along each axis. So it's the starting point to look at this problem. We're thinking about designing strategy-proof mechanisms for facility location. I want to look at a somewhat neglected objective, somewhat surprisingly neglected objective, that of equitability. It's a fundamental fairness property, trying to ensure that all agents are as equally happy as possible, but one that has received remarkably little attention, especially in the terms of mechanism design for facility location. Now, in economics, the most common, most fundamental measure of equitability is the Gini index. And we're going to be looking at the Gini index. This is the mean normalized difference in values. It's a fundamental measure of equitability. When the Gini index is 0, it's the most equitable, all the values are the same. And when the Gini index is 1, it's the most inequitable. You have one large value and all the rest are small. We're going to be looking at the Gini index of utilities, and not in fact the Gini index of distances. That's going to be an important difference. It turns out that that gives you better results. Utilities here, we're thinking of agents and facilities located to a fixed interval. In this case, 0, 1, but it could be any interval. Supposing we normalize by the size of the interval. And so the utility then is 1 minus the distance the agents have to travel. So thinking about strategy-proof mechanisms for facility location on the line, the most natural, the simplest strategy-proof mechanism you can think of is the median mechanism. Locate the facility at the median agent. Unfortunately, it's quite easy to show that we don't get a bounded approximation ratio of the Gini index of utilities. Now, you might be disappointed that the median mechanism doesn't doesn't give you a bound on how well it approximates the Gini index of utilities, but this is in some sense inevitable. It's quite easy to prove that no strategy-proof mechanism for one or more facilities has a bounded approximation ratio of the Gini index of utilities. It's not just the median, that there's no strategy-proof mechanism that's going to bound the approximation ratio of the Gini index of utilities. When you look into what's happening here, the challenge here is that to get a good approximation ratio, you have to worry about when the objective, the Gini index of utilities, is close to 0 or close to 0. You have to approximate those instances well, otherwise you won't get a bounded approximation ratio. But that's focusing on the equitable problems where the index is 0 or close to 0. It's distracting us from the problems which have some inevitable inequitability, where agents are distributed in a way that we cannot ensure that every agent is equidistant from the facility as possible. And so to look at those instances and to get bounded approximation ratios, we propose instead looking at the complemented Gini index of utilities. That's 1 minus the Gini index. That's again a ratio that's between 0 and 1. But now it's 1 when problems are equitable and 0 when problems are inequitable. And that's now shifting our attention when we're thinking about approximation ratios to those necessarily inequitable problems where the Gini index is not far from zero. Now, good news immediately, the median mechanism now has a bounded approximation ratio. It too approximates the complemented Gini index of utilities. We can, however, do better than that. The mid or nearest mechanism locates the facility at the midpoint, if the leftmost and rightmost agents straddle the midpoint. Otherwise, it locates it at the agent nearest to the midpoint. That's the mid or nearest mechanism. That has a much significantly better approximation ratio of the complemented Gini index of utilities. It's a 6/5 approximation of the complemented Gini index of utilities. And indeed, we can prove that this is optimal, that no strategy proof mechanism can do better than a 6/5 approximation ratio of the complemented Gini index of utilities. In the paper, we look at some other settings, more complicated settings. So, for example, we look at locating two facilities. The natural strategy proof mechanism to think about here is the endpoint mechanism that locates one facility at the leftmost agent and the other facility at the rightmost agent. That provides a 1.21 approximation ratio of the complemented Gini index of utilities. If we truncate the locations of the facilities to be within the interval a quarter, 3/4, so away from the endpoints, the extreme endpoints, then we get an even better approximation ratio. We get a 1.07 approximation ratio of the complemented Gini index of utilities. And we can prove that that's not optimal, but it's not far from optimal, that no strategy proof mechanism can do better than a 1.03 approximation ratio of the complemented Gini index of utilities. And so it's an interesting open problem to narrow that gap between 1.03 and 1.07. So I don't have time to go into many more of the other results in the paper. I encourage you to come to the presentation at IJCAI to read the paper itself. But just to end with some conclusions, what turns out it was really important to find the right objective. Here, it wasn't the Gini index of utilities, it was the complemented Gini index of utilities, and it wasn't also the Gini index of distances. And the paper we go into why the Gini index of distances or even the complemented Gini index of distances wouldn't be the right thing to be looking at approximating. And when we get that appropriate objective, it turns out there's actually quite a rich space of approximate strategy proof mechanisms. We saw the mid or nearest, we saw the truncated endpoint, there's some others in the paper. And this allows us to focus on the challenge of approximating challenging instances where some agents are necessarily far from the facility. And an important consideration, turns out to be important here and also in my other presentation at this workshop, is that truncating extreme outcomes is often very helpful. Thank you very much.